Hi everyone. Now let's get started with Agile environment. Usually the project environment includes the physical space and software tools used by the developer. This section includes a few environment tips to support iterative and agile development. The first one is continuous integration. Continuous integration is the process of taking the features from the program backlog and developing, testing and integrating and validating them in a staging environment where they are ready for deployment and release. So it is a critical technical practice for each agile release train which improves quality, reduces risk and establishes a fast, reliable and sustainable development pace. So with the continuous integration, the system always runs even during the deployment. Continuous integration is also useful in other iterative and incremental development methods, and it is a refinement and more frequent version of the daily build and mock test practice popularized at Microsoft. It involves producing a clean build of the system several times per day with the help of a tool like cruise control. Agile teams typically configure continuous integration to include automated compilation, unit test, execution, and source control integration. Continuous integration is the second aspect in the continuous delivery pipeline. The continuous delivery pipeline consists of the following, and they are: first one is continuous exploration, continuous integration, continuous deployment, and finally release on demand. In the figure you can see continuous integration is the second aspect of continuous delivery pipeline. Continuous integration consists of 4 activities, and they are the following. The first one is develop, second one is build, third one is test end to end, last one is stage. The following figure shows the different activities of continuous integration. Now we will describe each activities in brief. The first one is develop, that is developing the solution. Developing the solution refers to the implementation of stories by refining the features from the program backlog as may needed, and then we will be coding, testing and committing the work product in the source control system. Here, the testing in these activities tends to focus on unit and story level testing. The next activity is to build the solution. This activity includes continuous code integration, build and test automation, and application history. The third activity is test the solution end to end. Here, the system level testing happens as frequently as possible during the iteration after every commit. Whatever the circumstances happen, the full system integration must be accomplished at least once per iteration. Otherwise, the late discovery of defects and issues reflects back to the earlier iteration, causing the substantial reworks and delay. This activity includes test automation, test data management, testing the non-functional requirements, and service virtualization. The last activity is stage, that is validate on staging. In this activity, the entire solution must be validated on a staging environment. Project wiki webs. Another common agile environment used is project wiki webs. Most of the people are familiar with the blogs or web blogs that allow one to easily write and publish to web pages. The older and the more robust version of this idea is wiki web technology. Like blogs, wiki webs allow people to edit web pages using only their browsers. They allow one to easily create new pages and hyperlinks between the wiki pages using only a browser and special wiki words. The next one is case tools and reverse engineering. The UML oriented case tools support both forward engineering and reverse engineering. So what is forward engineering and reverse engineering? Forward engineering is nothing but generation of code from diagrams, and reverse engineering is generation of diagram from code. If an agile oriented project uses a case tool, it is most often simply for the reverse engineering features to support the visualization and the more visually oriented on the team. For example, suppose when an agile team member coach a team through an iteration, they print reverse engineered UML diagrams zoomed very large on a plotter and stick them on walls. Some of the developers use the plots during the discussion or short design sessions sketching on them. Now consider a plotter. Visualization of information on the wall is promoted in agile methods. The large diagrams and font size are important for easier viewing. Printing large zoom documents on a laser print is laborious. Laborious is nothing but requiring the considerable time and effort to work. So a wide plotter is faster and easier way to do. Caves and common room. Another agile environment is caves and common room. The agile methods promote development in a common room rather than in separate offices to increase the communication. It is a required practice in Scrum and XP, but at sometimes people also have need for privacy. The caves and common room also promote separate private office spaces that developers can use during the non-development activities. Clean sheets or whiteboard paint. Agile modeling promotes the use of whiteboard space and freehand drawing for creative modeling work. If whiteboards are not be available, they consider using clean sheets or static clean sheets. These can be purchased at most of the office supply stores and come in packages like flip chart paper. Actually, they are made up of a very thin, white, flexible plastic material that has a static charge. You can use a whiteboard marker to write and erase on them as with any whiteboard. Another alternative is the use of whiteboard paint. Last one is digital cameras. Digital cameras, or at least a phone with a camera, can be used to take snapshot of your modeling artifacts. The common uses of digital cameras are to take pictures of critical diagrams and paper-based models, and also to capture hand-sketched whiteboard models or lists, etc., so that it may be shared electronically. Consider the figure and you can see the project environment, which includes the physical space, software and hardware used by the developers. The software includes the continuous integration tools, project wiki, UML case tools, and the hardware includes digital cameras for capturing the hand sketched whiteboard models and lists, whiteboard paint, projectors, etc. Thank you.